I would have imagined a world where I could have said, well, we're getting tons of data, language data, out on exactly the domain we care about. The large language models that sit at the bottom of our stack are quite expensive from an inference point of view. They're quite slow from an inference point of view. You don't need a foundation model for what you do because very few of your customer service things are going to involve reciting digits of pi or talking about Macbeth or knowing when the Hundred-Year War was. Like, I assume most customer service doesn't involve any of that. And so I could have imagined a world where you're using your data to effectively distill down to a very small foundation model that works for your purpose. And it would be quite unique in class and would give you, you're almost setting yourself up for a distillation step. And that would have, I thought, give you, is that?
Absolutely, absolutely. And the way that you think about, I mentioned that we have this decomposition of the problem, or the solution rather, into multiple different modules,
Yeah,
right?
yeah,
What we're generating there that is extremely interesting is this step-based reasoning data for every customer service inquiry that comes in. It's so much more valuable than the actual chat transcript or call transcript, because the AI agent is effectively showing its work, right, and all things it's considering along the way. So this is an area that we're thinking about a lot, and we're thinking about it particularly on our voice modalities, where it hits us the most frequently, because we just don't have the same latency flexibility that we have on voice as we have on other channels. So this is an area where we're actively working with distillation and fine-tuning to be able to use much smaller, quicker models and approach similar performance on the reasoning step. We've had some really good results there so far. Still, I think the models that we've been successful with don't hit our latency threshold yet. I think this is the path where we're going to get, I think, ultimately orders of magnitude decreases in latency and in essentially cost of goods
yeah.
sold for the business.
But can I even push you a little bit? I understand why
Sure.
you're doing it in the multimodal bit. I think if we think of this as supervised learning, I could have imagined a world where you're actually making the supervised learning steps much faster.
Mm-hmm.
If even for your base model that you use to make the call, if that foundation model is a distilled, more specialized model, because you just have a lot of interference. I mean, it sounds nice to have a pretty big language model, but it can be a distraction. And so it is astonishing how much data you're getting. And so I'm just
You're absolutely right. I'm not disputing you being right or not. I think here what you're running up against is effectively our business constraints. So
yeah,
we're selecting right now to optimize for depth of reasoning and quality of resolution that we can achieve.
fantastic. Yeah,
And we're doing what we can with a limited resource. So the latency problem is something that we have no other option to bring latency down other than a distillation task. On the others, because we have a budget on compute that we can use and like brute force, essentially,
yeah,
we'll brute force it now. But like, we're going to hit the limits of what this can be from our perspective fairly quickly, and for a number of reasons, not just because ultimately it's going to come down to the kind of performance that we want to have. We want it to feel really magical, instant, all of those qualities. Getting there is going to be through that path. I completely agree with you.